Hello students, welcome to the fourth and the final lesson in this chapter on solving trigonometric equations. We have dealt with basic equations and equations involving multiple angles in the previous chapters. Now we are going to deal with situations where the trigonometric function itself is raised to a power, right? Like x square, you solve linear equations and then quadratic equations. In the same way, trigonometric equations of the quadratic type. And we will stop with that concept, but you can then extrapolate these ideas and solve equations that involve higher powers of those functions like cube and power 4. In fact, there's one example where you see exponent of 4. Okay. So what are the tools needed or what concepts shall we use? Most of the basic techniques that you have learned before will be again reused. But apart from that, some other ideas that we will need are listed in these bullet points. Not you won't need all of them in every question. Okay, depending on situation, we will use one or more of these. The first skill, of course, is you need to know the values of sine, cosine, and tangent. I mean, standard values. Okay. And if it is not a standard angle, you will use the calculator with the inverse trigonometric function and get the smallest positive angle. And then we use other known techniques, right? The horizontally on the other side for sine, vertically on the other end of the unit circle for cosine, and 180-degree um, on the other side for tangent, right? And sometimes you might have to use substitutions to solve the equations. We will see some examples. Because these are going to be quadratic equations, you may have to factorize. If factoring is not possible, you might have to use quadratic formula. Okay. And sometimes you'll see an equation which involves like sine and cosine or secant and tangent, and um, there is no obvious connection between those identities, those functions. In that case, you can square them. There are other techniques also, but in this course, the way we have been developing the ideas, uh, we will be more comfortable using Pythagorean identities. Okay, what will that do? If you square the equation and convert sine and cosine to sine square and cos square, then you can write sine square in terms of cos square and cos square in terms of sine square using Pythagorean identities, and then you can solve it. So that will be one idea you might want to keep in mind: squaring both sides and using those identities. And sometimes you will be able to use some other identities like um, sum to product or product to sum identities of trigonometric functions. So you can convert, the equation so that you have only one trig function at the end. Like the given equation might have sine and cosine, but you rewrite in such a way that you have only sine at the end. Okay. When you see an identity, most of the time the form of the equation will be obvious. Okay, we'll make it clear which identity to use. You need to know the identities in your mind. Okay, all the identities that we have studied previously, if you remember them well, you will be able to spot them. Okay, in this equation I can use that identity. All right, let us solve some examples. Sine of minus x equals cos x, and you have to write solutions on this interval. 0 to 2 pi. Okay. So where can I begin, right? The first thing I can do is remember sine is the odd function. So sine of minus x is minus sine x. Sine x is an odd function. Okay. So minus sine x equals cos x. And you get that. Um, Again, that itself doesn't help much, right? So I was saying a while ago, maybe you can square and use Pythagorean identities. That's one idea. Okay. You get sine square x. Now when you square, it's you lose the distinction of plus and minus, right? So you get sine square x equals cos square x. But cos square x can be written as 1 minus sine square x. So now sine square x plus sine square x equals 1. Okay, bring that sine square x to left side, becomes plus sine square x. So 2 sine square x equals 1. Now this is in terms of only one function, we can solve it. Sine square x equals half. So don't think of sine 30 degree or pi over 6 because that is sine square x. Sine x is plus minus under root of 1, under root of 2. Okay, take the square root on both sides. So two possibilities. Sin x equals 1 over root 2 and sin x equals minus 1 over root 2. Now, which one? So you will get different solutions. You have to verify them. Okay. Because you have squared it, in the process of squaring, sometimes additional solutions appear which are not correct, which are not true. Okay. So once you find the angles here, we have to go back to the original equation and check and keep only those which satisfy the equation. Let's do that one by one. Okay. From sin x equals 1 over root 2, the positive value there, which is root 2 over 2, if that is easy for you to remember. You can say the values of x are what? Pi over 4 in the first quadrant and 3 pi over 4 in the second quadrant. Now, this is your basic knowledge from the unit circle. Okay. Sin x is positive in the first quadrant and second quadrant. And I'll continue up here from sin x equals negative root. You get now sin x is negative in the third and fourth quadrant, and the reference angle here is pi over 4. Okay, for 1 over root 2. So in the third quadrant, pi over 4 will be pi plus pi over 4, which is 5 pi over 4. In the fourth quadrant, it will be 7 pi over. You can, however way you know how to find those angles, use that knowledge. Okay. So we have 4 solutions here. Pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. But not all of them might be true. Okay. So what you need to do, check. Check with what? Original equation. Okay. And the original equation will be easy to use before you squared. So I'm going to go here and I'm going to check with this. Okay. Because that was the equation before we squared it, right? minus sin x equals cos x. And I can straight away discard some of them. For example, I'll use green color now. Okay, so let me segregate the two parts. Uh, 1 over pi over 4 is not going to work, I know, because minus sine pi over 4 equals cos pi over 4. Not true. In the first quadrant, both are positive, right? You cannot have negative equal to positive. That's not true. Whereas if you go to 3 pi over 4, minus sine 3 pi over 4 equals cos 3 pi over 4. That is true. Why? Because sine is positive in the second quadrant, cosine is negative. So minus sign will be positive, right? This will be minus 1 over root 2, and that is also minus 1 over root. So in fact, I can say that the angles which are in the second and fourth quadrant will be the solutions, and the ones that are in the first and third will not be the solutions. Okay? Or I might have misspoken that. Let's do it one by one. Okay? If you go to 5 pi over 4 minus sine 5 pi over 4 will be positive. Whereas, yeah, I was right. Okay, cos pi over 4 will be 5 pi over 4 will be negative. Because we have limited spot here, I'm not writing it, I'm spelling it out. Listen and make sure you understand. Okay. Sine 5 pi over 4. 5 pi over 4 is in what quadrant? All of them are 1 over root 2s. Okay. It's only a question of plus 1 over root 2 or minus 1 over root 2. 5 pi over 4 is in quadrant 3. So this quantity is negative. And if you put a minus in front of it, the whole thing becomes positive, right? Overall, it is positive. Whereas cos 5 pi over 4 is negative root 2 over 2, which is negative. So negative of negative and negative are not equal, right? So the two sides are not equal. That's not true. And finally, if you go to the fourth quadrant, you get minus sine 7 pi over 4. Now that is negative of negative, negative of negative. It will be positive equals cos 7 pi over 4. In the fourth quadrant, cosine is positive. So negative of negative is positive. Positive equals positive. Works. Hence, I will now zoom in and highlight the angles that are solutions. Okay, 3 pi over 4 and 7 pi over 4 are solutions. The other two are not. Okay. And once again, I will repeat, why did we why did we end up getting values that are not solutions? That's because we squared the equation. And whenever you square an equation, you are going to get that. Okay. At the end, you need to check your angles and keep those which work. Okay. Move on. 2 tan square x equals tan x. Now this is a quadratic equation clearly. Okay. Already given. So you can write like this: 2 tan square x minus tan x equals 0. In the bullet points that we read earlier, one of the strategies was factorize if possible, right? So clearly you can factorize this equation. Okay. and you get two equations now. Tan x equals 0 or 2 tan x minus 1 equals 0. Okay. If tan x is 0, then x can be 0 or pi, right? Tan x is what? Sin x over cos x. That means sin x has to be 0, and that is at 0 and pi. Whereas if 2 tan x minus 1 is 0, then tan x is 1 over 2. Now, half is standard value for sin x and cos x, not for tan x. Okay, you have to use a calculator. X will be tan inverse half, and because it's a positive value, you will be able to find one angle in the first quadrant, and the other angle would be obtained by adding pi to it. That will be in the third quadrant. Okay, um, I will write that using the calculator. I got 0.464 rounded to 3 decimal places. Okay, make sure to have your calculator in radian mode. That's one of the angles. If you are writing exact solution, you can leave it at this, by the way. Okay, you don't have to necessarily do it in decimals. Um, um, you can just say tan inverse half. Okay, and say that it is in the first quadrant. I will show you how to write that also. And the the other solution would be pi plus tan inverse half. Okay, and now combining everything, I will write the answer now. Okay, answer to the question the solve will be x equals, I will put it in a set. Okay, 0, pi, theta, and pi plus theta. Okay, these are the four solutions where theta is tan inverse half in first quadrant. That's how you can express the solutions. Okay, and if you need to express in decimals, as I said, you can use that 0.6464 and pi plus 0.464, right? Those will be your two solutions. Anything is fine. Okay, as long as you articulate your answer completely. And in this case, I'm not going, I mean, you can check your like angles plugging in the equation and making sure they work. But I'm certain that I don't have to discard any of these, unlike in the previous example, because we did not do any squaring on our own. Okay, the equation given as it is was quadratic. We did not square it. So none of these solutions are, I have been avoiding the word before, but I'll use now. None of the solutions are extraneous. I hope my spelling is correct there. Okay. Now, when you get solutions, when solutions arise in an equation and they finally don't work, they're called extraneous solutions. Okay. So these four solutions are not extraneous. Okay. Another equation. Again, this is quadratic, but one is sine square, other is cos. So two different functions here. And going back to the strategies that I read, you want to convert them into same function, right? Have everything in terms of sine or everything in terms of cosine, which is easier. Obviously, there is square here. It's easy to convert that sine square to cos square using Pythagorean identities. So 6 times 1 minus cos square x minus 2 cos x equals 5. Okay. So everything is in terms of cosine now. Let us expand it. Minus 5 equal to 0. I'm going to write it in the standard form where ax square plus bx plus c equal to 0 in that form. Okay. So minus 6 cos square x minus 2 cos x plus 1, 0. And then you multiply by negative sign, becomes 6 cos square x 2 cos x minus 1, 0. Okay. Ax square plus bx plus c equal to 0. If you can see how to factor it, go ahead and do it. If you don't see it, use the quadratic formula. Okay. I will use the quadratic formula for the convenience of most of you watching it. Okay. But if anybody is interested in factoring and are looking for a hint, I can tell you the product should be 6, right? 6 times 1, and the difference should be 2, the middle coefficient. Okay. Think of two numbers. The difference is 2, product is 6. Do we find that? Okay. If you don't find it, then there's no factoring. Okay. I might have misspoken. I was thinking there is a factoring possible, but may not be. I don't know. Let's go with quadratic formula. Okay. What do we get? Cos x equals, I'm writing it here. Hope you remember the formula. Okay. The formula is, if the equation is in x, minus b plus minus under root b square minus 4ac divided by 2a. Right? That's the formula. So using that here, minus 2 plus minus under root 2 square will be 4 minus 4ac divided by 2a. b square minus 4ac. 4 plus 24, 28 divided by 12. And how can we simplify this number? 28 is 4 times 7. So you can write it as 2 root 7 over 12. So cos x equals minus 1 plus minus under root 7 divided by 6. Okay. Now clearly these are not standard angles, right? So from here, so that means we have to write solutions in using the non-standard method, what are going to be my two different cos x values here? I'll separate them out and write. Okay. Cos x equals minus 1 plus root 7 over 6, and cos x equals minus 1 minus root 7 over 6. Okay. So from here I can say that x will be cos inverse. I am writing root 7 minus 1, just uh, changing that order. Okay, just so that I can mentally see it easily that this will be positive value. Under root 7 minus 1 over 6 is positive, right? Call it theta in quadrant 1. Because that number is positive, cos inverse will be some angle in first quadrant, quadrant 1. Okay. And on the right side, you get x equals cos inverse of negative root 7 minus 1 over 6. We're writing in a similar format for consistency. But clearly that number is negative root 7 minus 1, because that is negative, call it beta, and that will be in quadrant 2, right? Cosine will be negative for the first time in second quadrant. Okay. Using those, you can write your solutions. Okay. Solutions will be, therefore I would say solutions are theta, and this is cosine, right? Minus theta, beta, and minus beta, where theta and beta are as above. Okay. And this you might remember, I mentioned, I think, in the previous lesson also, when you have cos x equals cos theta, there are two solutions, theta and minus theta, because cos is an even function. Cos of minus theta will be the same as cos theta. Okay. So if you know one angle, you can get the other angle by just taking the negative of that angle. If you want to write it as a positive value, then you can add 2 pi to it and make it positive. But the equivalent value will be negative theta. Okay. And again, I don't have to discard any of those solutions because the equation as it is given was quadratic. So all those four values would be true. Okay. In fact, if you want, I can give you the quadrats. Okay. Theta is in first quadrant. So minus theta will be in the fourth quadrant. Beta is negative value. So we said the smaller of them will be in the second quadrant. And if beta is in second quadrant, if you take minus beta, you go clockwise, you'll reach third quadrant. Okay, so those will be the quadrants of those angles. And if you need decimal value, put that in a calculator. Okay, all right. Solve cos 2x cos x minus sin 2x sin x equals half. When you see that, now I was saying earlier that when you see the expression, you will know what identity to use. Okay, take a moment and think if some identity is coming to your mind. Okay, and it should be this: cos 2x plus x equals r. What's the identity? I'll write that as the reason, because cos A plus B equals cos A cos B minus sin A sin B. We're using that identity. Okay. So cos 2x plus x in this case. That's the reason statement. So let me change its color. Okay. Continuing here, this implies cos 3x equals half. And now we are back to multiple angle from the previous lesson. So I'm hoping you will be able to solve on your own after this. The question does not say on what interval. So that means you are writing general solutions. Okay, write general solutions, all possible solutions in terms of k. Complete it by yourself from this point onwards and then check with me. Half happens at cos pi over 3, right, on the unit circle. Okay, and that means 3x is pi over 3, or the counterpart of pi over 3 will be minus pi over 3. I do some work on the side here. Okay, I want to write angles in positive terms. Oh, not necessary actually. We are writing general solutions. Sorry. So I'm going to just write plus minus pi over 3. Okay. 3x is equal to plus minus pi over 3. And because cosine is periodic with 2 pi, you can write plus 2k pi. That gives you x equals 2 pi over 3 k plus minus pi over 3. And if you want to write that neatly, you will write it as 2k plus minus 1 and factor out the pi, where k is any integer. Okay. Once again, I will repeat. If you know one smallest positive angle, theta, for the solution of cosine, okay, if you know the angle theta, then the other solution is minus theta. Okay. Hence, plus minus pi over 3. But then you have to write all solutions, right? So you add plus 2k pi, and that is 3x. Divide by 3 on both sides. That will be for x. I think I made one calculation mistake here. It should be divided by 9. No, divide by 3 here, divided by 9 here. Plus minus pi over 9, because it's pi over 3 divided by 3. Okay. So I should be careful here. If I should be taking 9 as I should factor out pi over 9, and that should give me 6k plus minus 1. Okay, I corrected that. Okay, moving on. Solve tan 3 theta plus tan 2 theta over 1 minus tan 3 theta tan 2 theta equals that on the interval 0 to 360 degrees. Okay, now you remember the identity. It is tan 3 theta plus 2 theta. This one. That expression is the formula of tan A plus B. Okay. Tan A plus B equals tan A plus tan B divided by 1 minus tan A tan B. Okay. That is so simple now. Tan 5 theta equals 1. 1 is tan pi over 4. So the values of 5 theta are pi over 4. Oh, I should write in degrees. Pi over 4 means 45 degrees. Okay, 45 degree. And the subsequent values are plus pi. Remember, that is for tangent. Okay, so plus 180 degree. So 45 degree, and that will be 180 degree plus 45 degree, 360 degree plus 45 degree, and so on. How long do you want to continue? Until you get theta between 0 and 360. Okay, right now, for example, I will skip a line and write here. If you want to get theta from here, we'll divide by 5. We have done this in the previous lesson. I hope you are remembering. Okay, now you divide by 5 on both sides. You are going to get 9 degree. That will be 36 plus 9. That will be 45. The next one, when you divide by 5, that is 72 degree. Basically, 180 degree divided by 5 is 36 degree. So it is going to be multiples of 36 degree. Okay, 36, then 72 plus 9 degree. That means there are many more angles to come, right? The next one would be 108 degree plus 9 degree. Next would be another multiple, 144 degree plus 9 degree. And then add 36, 180 degree plus 9 degree. And I can kind of see the pattern now, 216 degree plus 9 degree. 236, 22, 252 degree plus 9 degree, 288 degree plus 9 degree, 324 degree plus 9 degree. The next one will be 360 degree plus 9 degree, and that will be more than 360. Okay, so we stop at that. Here I can just say continue. All right, just simplify and make the list now, and we're done. Theta equals, I'm going to put them in a set now, 9, 45, 81, 117, 153, 189, 225, 261, 297, 333. Okay. Solve cot 4 theta minus cot square theta plus 3 equals 0. So that's degree 4 equation. Two things. We are going to convert that cot to tan at a later point. Okay. That is one. The other thing is how to deal with the power 4. Luckily, this is cot to the 4 and then cot square. You don't have cube or cot. Okay, you don't have cot cube theta and you don't have cot theta. Odd degrees are not there, only even degrees are there. which is always useful. Okay. So what you do is you say let x equals cot square theta. Your substitution. That was the U substitution mentioned at the in the strategies earlier. I'll use x, okay, but substitution basically. And how does this help? And this is one of a kind thing you have to learn and remember. Okay. Once you say x equals cot square theta, then you are going to get cot to the 4 is x square now. X is cot square theta. So x square will be cot to the power 4 theta. Okay. So x square minus 4x plus 3 equals 0. Okay. And that can be factored. X minus 1, x minus 3 equals 0. Okay. So you get either x equals 1 or x equals 3. Now, what is x equals 1? Cot square theta equals 1. So that gives you tan square theta equals 1. Reciprocal will be itself. Okay. So tan theta will be plus minus 1. And you get two things from there now. Plus minus 1, what are the values? Okay. Theta will be, if you go with plus 1, you get pi over. Do we have to write in degrees? No. We just say general solution. Doesn't mention anything. General solution. So you will say pi over 4 plus k pi with 1, and minus 1 happens in the second quadrant. 3 pi over 4 plus k pi. Okay, that's on the left side. On the right side, you get x equals 3, which is cot square theta is 3. So cot theta is plus minus under root of 3. So tan theta will be plus minus the 1 over under root of 3. Now you know that is root 3 over 3. So the angles are root 3 over 3. The positive value is in the first quadrant, that is pi over 6. So plus k pi. And if you take minus 1 root 3 over 3, that is in the second quadrant. And that is 5 pi over 6 plus k pi. Okay. So you have 4 solutions. You can combine them like this. Okay. Finally, you can write solution like this. You can say therefore theta equals, okay, alpha plus k pi. Okay. Solutions are, let me write it in the set builder notation. I'll write here the solutions are, therefore, okay, therefore the solutions are theta such that theta equals alpha plus k pi, where alpha is 1 of pi over 4, 3 pi over 4, pi over 6, or 5 pi over 6, and k is any integer. There are different ways of writing. As long as you get these four solutions, you're good. Okay, you don't have to worry too much about the way I wrote here. If you can pick up that, well and good, but know how to solve and get those four solutions primarily. Okay, all right. We are towards the end of the chapter. We have one last question, and this is a word problem. Okay, a block is set in motion hanging from a spring and oscillates about its resting position according to that function. For what values of t is the block at its resting position x equals 0? Okay. The solution itself is not that difficult. We'll figure that in a second. For now, the first thing is we want to understand what's going on here. So the whole problem makes sense. Okay. So there is a spring, and this is a word problem we have seen before also, right? The motion of a spring, okay, is controlled by the sine wave. And this is the resting position when you have not touched. This is the resting position, and that height, okay, at resting position, that height is 0. Okay, at that level. And there is a scale there for the height, and 0 corresponds to this height. Then you can have, you can define what is positive, what is negative. Okay, 1, 2, let's 3 there, let's say, and then -1, -2, -3, and so on. Okay. Um, the question is at different times, once the spring is in motion, at different times, the height where the block is, is given by this equation. Okay. And we are asked at what times will it be in the resting position, because the block is going to move up and down, right? So it is going to move past that resting position in its every cycle, twice in every cycle actually. When it is going up, it will pass through that, and when it is going down again, it will pass through that. So we want to know at what times it will be reaching that x equals 0 level. Okay, that is the question. Now the solution is here, which can be detached from that, but I just wanted to make sure you understand what's going on. Okay, the solution is solve what x equals 0 for t, I mean. Okay, x equals 0 means minus 0.3 sine 3t plus 0.5 cos 3t equals 0. Okay, and we will go ahead and solve it now. Minus 0.3 sine 3t equals minus 0.5 cos 3t. Okay, we're solving the equation now. That gives you, you want to solve for the t, right? So you combine them into, like, you want to get one single trigonometric function. The best way you can do that is sine 3t, bring the cos 3t to the left, divide. So sine 3t divided by cos 3t, cross divide, okay? Cross multiply or cross divide equals minus 0.5 divided by minus 0.3. So take the negative 0.3 to the right side and divide. Bring the cos 3t from the right to the left and divide, right? Multiplication becomes division on the other side. So that gives you tan 3t equals 503. Okay. So which means 3t is tan inverse 5 over 3 plus k pi. General solution, right? Question was for what times, okay, what values of t, and we have to write all possible solutions. So we add plus k pi. Okay, implies t equals 1/3. I'll call that angle theta. Okay, plus k pi, where theta is in first quadrant. Okay, first quadrant, and tan theta is 5. That's like we have done that before. That's one more language, to express the solution. Okay. And how do I know first quadrant? Because tan theta is positive here. So definitely in the first quadrant, there is one angle where tan theta takes that value. The range of tan theta is negative infinity to infinity. So I don't have to worry. Okay. There is going to be some angle whose value is 5 over 3. Okay. With that, we are done with this chapter. Thank you for watching, and I will see you in the next chapter.